Alright guys, welcome to this page of the notes, and I know, whoa, that's kind of a scary looking equation. I get it. We'll do a couple of these together just for you to kind of get the hang of how they work, but it's just like what we did with parabolas. It is completing the square, but actually, personally, I think these ones are a little bit easier to do, and you'll see why in just a second. Anyway, what I want you to do is I want you to find the center and the radius of a circle, given this kind of scary looking equation, and then you're going to go ahead and graph it. So let's just jump right into this and show you what you're going to do. What you need to do is you need to take this equation, which is not in vertex form, and put it in vertex form so that you immediately know the value of h, k, and r, which I ask you for all of. How do you do that? Well, you do that by completing the square. So here's what you're going to do. Go ahead and group the x's together, group the y's together, and anything that's left over, move to the other side. So here's what I've got. I have an x squared. I have an x squared, and I have a negative 8x. So I'm going to put those guys together, minus 8x, and I'm going to put them inside of parentheses, right? Because I want to keep those x's together. Then I have a plus y squared, so plus y squared, and I have a plus 12y, and I'm going to put those inside parentheses because they're my y's, and I want to keep them together. Now, what's left over? Well, I still have this negative 12 hanging out, and anything that didn't make it into the parentheses, right? Put the x's in here, put the y's in here. Anybody that doesn't make the cut, send them off to the other side. So I'll move this negative 12 to the other side, and this will all be equal to 12. Now, this should look familiar to you when completing the square from parabolas. Remember, with the parabolas, we group those x's together inside of our little workshop, so that inside the workshop, I could complete the square by adding b squared over 4. The only difference here now is instead of completing the square once, you will need to complete the square twice. You say, what? How is that easier than what we did with parabolas? Well, here's how it's easier. Remember, when we did it for parabolas, the whole equation was equal to y. So whatever I did inside the parentheses, I then had to subtract on the outside of the parentheses because I couldn't work on both sides of the equal sign. But this time, I've got a 12 over here. This is just a number. So now I think what makes this a little bit easier is whatever I add in here, algebra says you have to do to both sides. So whatever I add in here, I'll add to this side. And whatever I add in here, I'll also add to this side, and then the algebra is happy because I've added the same thing to both sides. My equation stays balanced, and I don't have to worry about that whole, adding something inside, subtracting it on the outside, yada, yada, yada. However, you will have to watch out for this leading coefficient does need to be a 1, must be a 1. So in the event that I ever give you a leading coefficient that isn't 1, you will need to pull that out, which means when you add it on this side, you will need to remember to put it back. Don't forget to put it back. But they both have a leading coefficient of 1 because this is our first example problem. Take it easy to get us started. Here we go. I need to complete the square, and that means adding b squared over 4. So we're going to have x squared minus 8x plus b squared over 4 plus y squared plus 12y plus b squared over 4. And on the other side, right, I added a b squared over 4 and I added a b squared over 4. Now, the way that I complete the square, right, it's b squared over 4 for both of them, but please notice the b's are different. Here the b is a negative 8. Here the b is a positive 12. These will not be the same number. Right? That's not what I'm saying. I'm not saying that whatever I add here, I also add here. That's not what I'm saying. It's just b squared over 4 is what you add to complete the square. But that's different for this set of parentheses and this set of parentheses. So please be very careful. What I add in here, I also have to add over here. In fact, actually, I will show you that those are going to be different numbers by using different colors. These will not be the same number. What I add here, while yes, it's b squared over 4, this number will be different than the b squared over 4 that I get here, because the b's are different. This b is an 8, this b is a 12. So now on the other side, I added this b squared over 4 in green. I need to add b squared over 4, which is in green. And in here, I add a b squared over 4, which is red. It'll be a different number. So on the other side, I need to add a b squared over 4. All right? So just make sure whatever you add to one side, you add to the other side. And that's why I think this one is a little bit easier than what we did with parabolas. Anyway, here we go. Okay, my b is a negative 8. So negative 8 squared is 64. 64 divided by 4 is 16. So I'm going to add 16 on the inside. Actually, here, let me do it in green. And then in red, my b is a 12. Well, 12 squared is 144, and 144 divided by 4 is 36. On the other side, I'm going to have actually, let's do, you know what? Nope, sorry, let me write it. I'm going to have 12 plus 16 plus 36. All right, awesome. Here we go. It's called completing the square because what I've done is this is a perfect square trinomial, and this is a perfect square trinomial, which means they both factor into binomials that are identical. They're exactly the same. Well, what two numbers, same two numbers, multiply to a positive 16 and sum to a negative 8? Well, that's minus 4. Minus 4 times minus 4 is 16, and minus 4 plus a minus 4 is negative 8. So I can just rewrite this guy as x minus 4 squared plus, all right, perfect square trinomial, which means both binomials need to be identical. I need two numbers that are exactly the same, multiply to 36 and sum to 12, and it's not that hard. 6 and 6. 6 times 6 is 36. 6 plus 6 is 12. So y plus 6 squared. All equal to, and then 12 plus 16 plus 36, my calculator says that that is 64. And look at that. There you go. This is the value of, actually, sorry, hold up. No, we're good. Let's call this guy right here, that's H. This guy right here, that's K. This guy right here, careful, that is, oh, I didn't write it, but it's right there on your formula sheet in standard form. It's x minus h squared plus y minus k squared equals r squared, right? So 64 is r squared, not r squared. So here's what I've got. I now know that the value of h, well, since it's x minus h, that means that my h is a positive 4. Since it's y minus k, but I have a plus 6. If it's y minus k, how do I get a positive sign in there? Well, the way it becomes a positive sign is if k is a minus 6, right? Because y minus a minus 6, the negative and the negative turn into a plus sign, so k needs to be a minus 6. And then, of course, r, not that difficult. If r squared is 64, take the square root of that to get r. And, of course, that would be 8. So there we go. My center is at 4, negative 6, and my radius is at 8. Let's see how this goes. Center is at 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right there is my center. And then my radius is 8. Now, the easiest way to count a radius is vertically and horizontally so that I can just count squares. 1, 2, 3, 4, 5, 6, 7. Right there is a distance, a radius of 8. And right there is a distance of 8. I need to sketch my circle so that it runs through those points around my center. And I think that maybe something that looks kind of like that is actually not too terribly bad. I'm slightly impressed with it. I'll take that. That's a pretty good sketch. Anyway, there's the graph of my circle, and I did it by completing the square. Again, just like we did for parabolas, except now you got to complete the square twice. What makes it a little bit more bearable is that I don't have to do all of the work on the same side. I can now work on both sides of the equal sign, which hopefully makes these, I think, makes these ones a little bit easier to do. All right, I got another one of these on the next page of the notes for you, so head on over to that page, and I'll meet you guys there.